7.10. This one's sort of neat. So we want to find h and g. I'm not going to call them that. I'll call them different things, and we'll get to that. But so write f equals f plus minus f minus, where f plus and f minus are both positive functions. This is the typical thing where you take, what do you take? You take f plus equal max of f and 0, and then you take f minus equal, you like take, what is it? You like flip f, and then you take, do you do the same thing? Do the max of negative f and 0. I forget what the exact details are, but you basically you do the typical thing where, like, if you have f and f is like this and this, then f plus is like this and f minus is like this. So yeah, you basically, f plus picks up the positive part and f minus picks up the negative part, but it's flipped to make it a positive function. So anyways, since f is in L1 mu, we know that the set where f is positive and, let's redo that, and f is negative, these sets are sigma finite. And that's because if they weren't sigma finite, then given any n, let's see here, if they're not sigma finite, then you can basically get a contradiction by taking unions of sets of large measures. You can convince yourself of this if you don't see it immediately. It's not a very tricky thing to check. So anyways, let epsilon be greater than 0. By proposition 7.14, there are lower semi-continuous functions GL plus minus, that's L for lower semi-continuous, and there's two functions here. There's GL plus and GL minus. And we've also got upper semi-continuous functions and these are GU plus minus. And these are such that each of the lower semi-continuous functions is greater than or equal to the corresponding f. And in terms of the integrals, the integral of f d mu minus the integral of gu d mu is less than or equal to epsilon over 4. And then what about the wait, this should be in GL d mu. Do I have that in the right order? No, I do not have that. That's why I was wrong. It was because I was writing the wrong line. So we've got this greater than or equal to this, GL plus minus d mu minus the integral of f plus minus d mu. Then we've got GU less than or equal to f plus minus, and finally, now this is what I wrote before, g d mu minus the integral of GU plus minus d mu is less than or equal to epsilon over 4. This is because we know that we can take a positive function and approximate it from above by lower semi-continuous functions. So that's what these GL plus minuses are. They're greater than or equal to f plus or minus, and because they're approximating f in the integral, what we can do is given this epsilon, we can choose a g which is greater than or equal to f, but not so much. It's only like epsilon over 4 with respect to the mu measure. That's how close we can get. We can get as close as we want, and we've chosen these to get epsilon over 4 close. And then, of course, same thing for the upper semi-continuous functions. Now here, what we need to do is, first of all, there's that extra assumption that gu plus minus is less than or equal to, is greater than or equal to 0, but that's fine. But the other important thing here is that when you apply proposition 7.14, here, the set that these functions are defined on has to be sigma finite. So that's why we needed f positive and f negative to be sigma finite sets, is to get these estimates with the upper semi-continuous functions. Okay, so now we are going to define new functions. GL is going to be GL plus minus GU minus, and GU to be GU plus minus GL minus. And if you haven't guessed, this GL is going to be our lower semi-continuous function H. No, lower semi-continuous function G, and GU is going to be our upper semi-continuous function H. But I'm not going to call them G and H. I'm going to call them GL and GU. Because when you have G and H here, you're thinking like, oh, what do those mean? Well, which one did I choose? Whereas here, you've got the subscript that tells you what it is. Like, oh, well, this is a L here, so this must be the lower semi-continuous one. So I think it's helpful notation. Anyways, now why are these functions what we want them to be? Since GU minus is upper semi-continuous, then minus GU minus is lower semi-continuous, and so GL is lower semi-continuous. And that's because we know that if you take two lower semi-continuous functions and add them, the sum is lower semi-continuous. That was one of the propositions near the beginning of the part on upper and lower semi-continuity. And then by similar arguments, which I'm not going to write them out, but GU is upper semi-continuous. You basically just flip the U and the L's and everything, and it just works out. What else do we need? Furthermore, we have GU plus less than or equal to F plus less than or equal to GL plus. And where is this? This is where F is greater than 0. And minus GL minus is, sorry, my L's kind of get messed up, but I mean, what can you do other than rewrite them a whole bunch of times? But that would take a lot of time. So this is on this set, and so GU is less than or equal to F, less than or equal to GL. Now you might be thinking, oh, well, what about when F equals 0? I really don't care. Just make these functions 0 there. We don't really need to worry about that. Because when we integrate over that region, it's just going to give us 0. So yeah, make sure GU and GL are 0 on this set. And is that something that we need to specify? Not really. Just maybe you could have said something like define functions GL plus minus on F. Here, I'll write that in. On. Well, you want to define it on F positive to have this property, but then you just want to make it 0 on the set where F equals 0. And then this will hold. So that's what you want to do. You want to make sure that GL plus minus, you want to make sure that GL and GU are 0 when F is 0. And everything else will be fine. So, lastly, and then now we just do some computations. Yeah, I'm going to make it look like not very neat and just kind of scrunch it all in there, but did my phone just turn off? No. Thank God. I just got a text. Okay, cool. I was really worried there. Here, you know what? I'm going to plug my phone in. I don't want to risk my phone dying. Just something it has been doing lately. So, anyways, what is the integral of GL minus GU d mu? Well, we want this to be less than epsilon, because that's what we need in our thing. But yeah, let's see what this is. This is integral of f negative GL minus GU d mu plus the integral for where f is positive GL minus GU d mu. Why am I not including where f is 0? Because we're defining everything to be 0 there, and so it doesn't contribute anything to the integral or to the sum. And so what we're going to do is we're going to add and subtract f a bunch of times, because that's what we do in analysis. If you want to get an inequality, you want to add and subtract a thing. Greater than 0. Oh man, am I going to fit this all? Greater than 0, f minus gu d mu. So yeah, we've just taken these two terms and added and subtracted f to make it into 4 terms. And now what we're going to do is we're going to write this as in terms of f plus minuses and g plus minuses. Because those are the things that we actually proved facts about. So less than 0, GL minus f minus d mu. Note that here we flip the signs because this is where f is negative, and so f minus is a positive function, so this is how you make it work. You have to flip the signs. But anyways, so you've got that, and then you've got f greater than 0. GL plus minus f plus d mu plus the integral of greater than 0 f plus minus gu plus d mu. Well, what is this less than or equal to? Well, we look at each of these 4 terms, and we literally just constructed these all to be less than epsilon over 4. So we've got 4 of them, so this is less than 4 epsilon over 4, which is equal to epsilon. I'm just going to write done here, so that doesn't take up more space. But basically, this is what we wanted. We have a lower semi-continuous function and an upper semi-continuous function, the GL and GU, and the GU is less than or equal to f less than or equal to GL, and the integral of the difference between the two integrated is less than epsilon, and that's exactly what we wanted. You know, if we want strictly less than epsilon, sure, let's get rid of these equalities here. It's not a big point, but sure, let's make it precise. But there we go, this completes the proof.